We just finished looking at the density curves and probability distributions. And before we move on, I want to take a look at these distributions that are pictured here. So you'll notice that each one of these follows those properties that we talked about earlier. So none of them drop below the horizontal axis or the x-axis. That smallest y value is 0, or the smallest probability is 0 on all of these. And then the area under each of these is actually equal to 1. Okay, so we have like an exponential curve and some other ones. The one that we're going to focus on in this chapter is the one over in the upper right, and that's our bell curve or our normal distribution. So a normal distribution is a type of probability distribution. It plays a huge role in probability and statistics. It's been studied and researched theoretically, as well as it has the most practical applications. So it's been studied theoretically and in the real world. Credit for this curve goes to Abraham de Moivre, late 1600s to mid 1700s. This is a Protestant Frenchman who immigrated to London in 1688 to avoid religious persecution. So, prompted by a desire to compute the probability of winning in various games of chance, so i.e. gambling, de Moivre obtained what is now recognized as a normal distribution. So by looking at the outcomes, making observations, calculating how often certain things occur, this normal distribution fell out of all of that. So normal distribution is really cool because it shows up in a lot of places. So normal distributions are good approximations to many kinds of chance outcomes, which is kind of the realm that de Moivre was working in. So things like tossing a coin many times, rolling a die. Normal distributions are also good descriptions for some distributions of real data. So things like scores on tests, repeated careful measures of the same quantity. So if I'm measuring something, there's always going to be a little bit of error in that measurement, right? So most of them should be really close to the actual value, but you'll get a few that are kind of a little further off. So that also follows that normal curve. This also includes characteristics of biological populations. So, for example, heights of people are normally distributed, lengths of fish, weights of bears, those kinds of things. And then lastly, normal distributions are the basis for many statistical inference procedures. So this includes things that we've talked about, like generalizing our results to our population and establishing cause and effect.